So our next method in 5.1 for factoring is a very specific approach, only potentially usable on a 4-term polynomial. And I also like to make sure and emphasize that it is not something that will always work. We have to try it and see if the steps follow through. Now you'll notice the very first step here says, if possible, factor out a GCF of the 4 terms. And that is, like I mentioned on the previous video, that will be something we will do every single time. Whether it's this method or any method, we will always say, first step, GCF. Now, for 4 terms, you gotta find something in common with all 4 terms. That's tougher to do. You know, notice I've got 6's here, but nothing here. I've got some with P's, some with R's, some with Q's, but nothing in all 4 terms. So we get a GCF of 1. Now that does not immediately make it prime. It just means the GCF didn't help us at all. So GCF is 1, but now we will use this method called grouping. And I'm just gonna walk through it rather than bother reading them to you. It makes more sense as we see them play out. So the first step, the reason it's called grouping, group the first 2 terms together and the last 2 terms together. Okay, 4 terms total. So I'm gonna start a set of parentheses with 6p minus 6q, and then put a plus sign in between those 2 and the next 2. And I'll come back and emphasize more of this plus sign for more future examples. So RP minus RQ. So first 2 and second 2 grouped. Now, step 3 has us using our GCF some more. Factor out the GCF from each group. The idea is, as 4 terms, they had nothing in common. But if I look at just 2 terms, they might have something in common. In this case, we see it's that 6. We can factor that GCF of 6 out, and then that same question of what's left over. Well, 6 times p to get 6p, 6 times a minus q to get the minus 6q. So that GCF of those 2 terms, leaving us with that. Now this plus sign is still there, separating this from this other group of 2, where their GCF now exists of an r, factoring out the r, and again, r times what is rp? Well, that'd be p, r times a minus q to get minus rq. So that's that step there, the factoring out the GCF of each group of 2. Now, it says here in step 4, if, and that is the key word here, if each group now has a common binomial, then factor out the binomial. So as we look at this line here, what we want to point out are a couple things. First of all, this right here is actually what we would call 1 term. It's this combined with this whole thing through multiplication. And then this right here is another term. And so as 2 terms, we notice this entire parenthesis expression there. So usually I refer to this as the big GCF, just to separate it from a standard GCF. The big GCF, meaning we're at that stage of the grouping process where these 2 things have to match. If they don't match, it didn't work. But if they do, we consider that to be like a GCF, and we factor it out. We say this thing was in common there and there. And so with that factored out, we want the parentheses. And although it looks confusing, it's the same idea. If I said p minus q times what gives me this thing, well, this thing is just 6 times p minus q. If you factored out that whole thing there, all you're left with is that thing out front, the 6. And then same for the other term. P minus q is the GCF factored out, leaving you just with this plus r. And that puts our polynomial into factored form. So with this, one thing I want to do real quickly for this first example, this thing I'm calling the big GCF, again, it can look a little confusing, especially from this step to this step. I just want to point out, if I took this here, and instead of writing the p minus q, if I just called it a, if I just said this is 6 times something, which I'm going to call a, plus r, well, that's the same thing, so call it a again, right? That's all we're saying. We're saying here are 2 terms that both have a, and if I factor out a, I'm left with a 6 in my first term and a plus r in my second term. And the only difference here is a is that whole parenthesis expression, right? There's the 6 minus r left over. The p minus q in common was just this thing down here I simplified by calling a. That's why this works. That's how this step gets to this step. You are doing nothing more than a quick GCF of this big thing, right? This big binomial. So let's take a look at a couple more examples here. So we see 4 terms, but the first step, always, first step, GCF. So 1, 2, 3, 4, I don't see any numbers in common or any variables in common. So again, GCF is 1. Once GCF is 1, and that's out of the way, then we can get to the actual process of grouping. Now, with this case, I'll group the first 2, x, y, minus 2y. But here's the deal. We are always going to put a plus between these first 2 and the second 2. Now, the fact that the third term is a minus 4x, that just means that for now, for the moment, we're going to call that negative 4x. Bring the minus, which is part of that term, into the parentheses. Now, from there, that next step was the GCF of each group. There's a GCF of a y in common with an x minus 2 left over. Here, we do see the 4 in common, but remember from earlier, that negative sign, we will factor it out, which means rather than just being a 4 being plus 4, factoring out a negative will make this a minus 4. And keep in mind that we did just factor out a negative 4 times x to get negative 4x, and negative 4 times a negative 2 to get a positive 8. Mentioned last time that factoring out a negative is going to switch every sign. But notice that was good, basically important, because we have to see these things matching perfectly. If this had been negative x plus 2, those don't match, we're going nowhere. But now they match, call it the big GCF, factor it out front, and then the question of what's left over. X minus 2 out of this term leaves you with just y. X minus 2 out of that term leaves you with minus 4. And there's our factored form. Moving on to the next one. 4 terms, but first step, GCF. Nothing in common between all 4 terms, so GCF is 1, so moving on. Again to groups of 2, Kn plus Mn, always plus, and then put that negative on that K. Now, these 2 terms, they've got an N in common. Factor out the N, a K is left there, a plus M there, so K plus M. Over here, nothing actually in common between those 2 terms, but again, negative sign out front. Let's try factoring out a negative. Now, since there's nothing else coming out, I like to put a 1 there. Anytime there isn't a GCF, or in this case a negative sign is GCF, I like to put that 1 there. I like to see something out front of those parentheses. It helps kind of avoid a common mistake of forgetting there's something there. But negative 1 times K, and negative 1 times a positive M to get that negative M. And again, that worked because that's what we had to see. So we can have our big GCF of K plus M and our leftovers of N minus 1. All right, and one more example. Oh, I lied. 2 more examples. All right, so again, we need to factor. So first step, have I got any say in GCF yet? That would be my plan. If we were in class, that would be exactly what I would have you do at this point. Get used to that. Get familiar with that habit of first step GCF. It will save your life many times. Now, in this case, it doesn't. There is still nothing in common, so GCF is 1, and we go on to the groups of 2. First group and second group. First group, we've got a 6 in common as far as the numbers are concerned, and an x in common with the variables. So factoring all that out, all that's left there, we didn't factor out the a. Here, we had to do 6 times a 2 to get 12, and we didn't factor out the b, but we factored out the x. So that's what's left there. This other group of 2, notice there's nothing in common. So again, like I mentioned in the last problem, I'm going to say, let's let there be a 1 of a GCF there, just to help us remember that's there. Because as you go to this last step, and we notice we've got the big GCF, you factor out the big GCF, and then you've got your leftover of 6x here, and you definitely want to make sure you see the leftover of plus 1 with that second set to get us our final answer. Also, I should mention, definitely should have mentioned this, anything you factor, you can check. You can check if it's the factored form, if it gets you back to where you started by simply multiplying it out, right? That's it. We're creating a multiplication problem that has this as an answer. In almost every case, other than some very, very specific forms of factoring problems, you can take your final answer and, as a check, just draw all your arcs, combine any like terms, and see if you get back where you started. Always remember to do that. That's a huge, huge benefit to have on these problems. But the last one here in the notes, one more, factor 4 terms. So first up, GCF. I'll just assume you said it. GCF, of those 4 terms, got some numbers and some variables, but nothing in common with all of them. So GCF is 1. And now, grouping into groups. 10x squared y squared minus 18y plus 15y squared minus 12x squared. Okay. As we go to do this grouping, we've got the GCF here of a 10 and all that mess, and an 18. Looks like it's going to be a 2. And so that's going to be 5, but then all that's still there, and that's going to be a 9. Over here, the only thing it looks like we got in common is between a 15 and a 12, which would be a 3. So 5y squared and a minus 4x squared. So notice we've done the first steps of grouping, but what we don't have, we do not have that big GCF, right? Those do not match even in the slightest. So this didn't work. Grouping does not work here. We don't go any further with this, right? That does us no good. However, we don't give up. There's one other option to try. And there's a lot of different ways you could potentially try other forms, but I'm going to tell you the one thing you can do to know if grouping would have worked or not. That is to take your 2 middle terms, right, the second and third term, and rewrite it with them in the alternate positions. So swap those 2 terms, turning this polynomial into, oops, that's a plus, putting the 15y squared there, and the minus 18 there. Okay? This one swap and the reattempt at grouping, this will show us whether this groups at all or not. Because again, I mentioned before, just because you see 4 terms doesn't mean it has to group. If it doesn't work here, this is the one change you can try to see if it would work in this form. So, throwing those terms into groups of 2, we get those 2 terms put together, and those 2 terms put together. Now for GCFs, between 10 and 15, we got a 5 in common. No x's, but we got a y squared. So 5 times 2 to get to 10. We still need all those x squareds, but y squared has been factored out. Plus 5 times a 3 to get 15, and that is all the y squareds that were there. So that's what's left. Moving on to the next set of terms. Between the 18 and the 12, we do see a 6 in common, but because of this negative, we will make it a negative 6. And as far as variables are concerned, there's no x's or y's here in common, so that'll be all we take out. So negative 6 would give us a positive 3 there to get a negative 18, and negative 6 times a positive 2x squared to get that negative 12x squared. So the question is, at this point, do our GCFs match? Notice 2x squared plus 3, that's just the other order, right? They're both positive. The order of those 2 terms would not make a difference. So yes, those do match. Whichever form you write is fine. I'll go with this form. That is our GCF, 2x squared plus 3. And now the leftovers, the stuff outside. The 5y squared minus 6. And there's our factored form.